All right, so let's imagine that this is your arm and this joint here is your elbow. And you have your biceps muscle that runs right here, okay? Now imagine that out here, right, you took and you were trying to lift a can of your favorite beverage, right? I'm trying to lift my can of beer, right? And so there is a force pulling on it, right? Which is gravity. And if I want to lift it up, I have to exert a force using this muscle here, okay? Now, let's use that same joint and imagine that here's my biceps muscle. Now, instead of a beer can being at the end of that joint, now I have a 30-pound weight that I'm holding on to, right? And so same thing is that there's a force acting on it of gravity. I want to lift it up, so I've got to exert force in this direction on that joint. Now, can the same amount of force that I use for the dumbbell, the 30-pound dumbbell, be the same as the amount of force that I use in order to lift a beer can? What would happen if I used that same amount of force that I'd use to lift the 30-pound dumbbell, and I use the same force to lift my beer can? Well, my beer can would go smashing into my face, right? So I can't use the same amount of force for each and every sort of muscle contraction that I do, right? So because of that, we have to essentially take our joint, take our muscle, and we have to be able to control the amount of force that we put on that muscle or that joint. So how do we go about doing that? Well, before we do that, we have to sort of remember that our muscle, if we look at our muscle, we're going to take our muscle in cross section. Remember that our muscle is divided into these groupings known as fascicles, right? And that each fascicle then had within it a given set of muscle fibers. So I'm only going to fill in 2 here for the sake of my argument, so I don't have to draw all of these little circles. Right, so there's my myofibers. Now, we know that the muscle is controlled by motor neurons. So this motor neuron will come down and it will actually sort of split off and it will hit like these 3 myofibers. Okay, now we have a different motor neuron. Let's do this one in sort of dark yellow. It's going to come down and maybe it'll hit this muscle fiber and this muscle fiber. Okay, and then let's do a green one. And this neuron's going to come down and it's going to hit maybe this myofiber and that myofiber. Okay, so green, notice that it activates 2 myofibers. Our dark yellow is 2 myofibers, and our yellow is 3 myofibers. So if I graph, right, the amount of force by a muscle, right, what's going to happen if I activate motor neuron, this motor neuron over here, right? Well, I get limited resting force is 0, and then I can get, let's say, that amount of force. Okay, then what if I do this motor neuron here? Well, if I activate that one, I will generate this amount of force here. What happens if I use this one here? Well, it's got the same amount of force, like so. But what happens if I say, let's do this in pink, what happens if I do these 2 together? If I send a signal down both of them, now I get a force that's equal to that, right? So what we have is that a motor neuron, so we'll write it over here, a motor neuron plus the myofibrers it synapses with is equal to something that we call a motor unit. Okay, it is a motor unit. So if we want to generate more force, right, what do? Instead of activating one motor unit, we recruit another motor unit to fire at the same time. So that is what we refer to as motor unit recruitment, and that's how we can generate more force. Okay? Now, as we sort of contract the myofibers, right, if we continuously contract each and every myofiber for indefinitely, those myofibers are going to fatigue. So what actually happens is that, let's say you've got motor unit 1, right? It will fire like so. And then motor unit 2 will fire like this. And then we can get, let's say, motor unit 3, and it might fire like this. Right? And then we'll go back to motor unit 1 again. Like so. Right? And so what happens is if we graph the overall amount of force that's being generated, right, what we get is sort of this like waving sort of amount of force. So if you take and you actually contract your muscle, and I mean like contract it as hard as you can, right, as physically hard as you can, you flex your muscles, right, what's going to happen is that muscle is going to shake a little bit, and that's because your muscle is going through something known as motor unit oscillation. Right? And that motor unit oscillation is this sort of pattern right here, where it just sort of oscillates a little bit between those motor units, and you get degreeing amounts of force generated with it. Right? So that is motor unit oscillation.